Hello students, today we're going to discuss JEE 2025 questions from most interesting chapter Electromagnetic Waves January attempt. So before getting into the video, we have a page in Instagram and WhatsApp channel. Do join in WhatsApp channel to explore more regarding physics and also to watch more video like this. Don't forget to subscribe our channel. Now we'll see the questions. We'll see the first question. A plane electromagnetic wave of frequency 20 MHz traveling in free space along positive x direction at a particular point in space and time, the electric field vector of wave EY is equal to 9.3 volt per meter. Then magnetic field vector of a wave at that point is. Then the question, an electromagnetic wave traveling in a free space, they have given the value of the electric field and they are asking the value of magnetic field. So with respect to this, we can choose the formula, that is V is equal to E by B. And also in question, they have represented as electromagnetic wave traveling in a free space. If it is in a free space, the electromagnetic wave will travel either in vacuum or air, so that we can change velocity of wave V as C, that is C is equal to E by B. So we need value for the magnetic field, so we can reform the formula. So you can write it as B is equal to E by C. Now we will substitute the value. In the place of E, we can substitute 9.3 and C is velocity of light in air or vacuum, which is 3 into 10 power 8. So if you calculate means this will become 1, it will become 3.1. So the answer is 3.1 into 10 power minus 8 Tesla. We'll check the option. Option 4 is the right answer. Next is a theory question. A plane electromagnetic wave propagating along positive x direction in free space. The component of electric field E and magnetic field B vector associated with the wave in Cartesian frame. So they are asking the direction for electric field and magnetic field. So always we get to know that electromagnetic wave, electric field and magnetic field, all the three will be mutually perpendicular to each other. That is, the wave will be perpendicular to electric field and magnetic field. So here the wave is propagating in x-axis. So the electric field will be along the y-axis and magnetic field will be along the z-axis. So you can write it as EY, BZ. We'll check the option. Option 2 is the right answer. Next, again a theory question. Statement type. Statement 1. Electromagnetic wave have both energy and momentum. So this statement is a correct statement. EM wave has both energy and momentum. Statement 2. Rest mass of a photon is 0. That is also correct. So both the statements are correct. So we'll check the option. Option 1 is the right answer. Next one, it's the most important question. The energy associated with the cylinder region due to an EM wave E is equal to 100 sin kx minus omega t is U naught. Find the equation of EM wave for a cylinder of same length and half the diameter as the previous one contains same energy U naught. Okay. So they have given two conditions. So let us consider cylinder. In first condition, they have a energy which is U naught and they have given the equation for the electric field. In this, maximum electric field is 100. Okay, so we can take E naught is equal to 100. Okay, and they have given length L and it has some diameter D. So coming to the second case, it's an identical cylinder but the length is same, diameter became half, which is D by 2, but which has the same energy U naught, and now we have to find the maximum electric field E naught. To handle this question, we can choose the formula energy density is equal to half epsilon naught E square, but they have given it as energy. So we're going to expand this formula. Energy density is equal to energy by unit volume, that is equal to half epsilon naught E square. Since it's a cylinder, I'm going to expand the volume. So we can write it as, in the place of volume, we can write it as A into L, area of cross section, into length L. So again we can expand area, we can write it as pi r square. So we can write energy pi, in the place of A we can substitute pi r square into L is equal to half epsilon naught E square. Okay, so just we can compare the two condition. The energy U naught is same, 1 by 2 epsilon naught is a constant, length is same, pi is a constant. So we need relation only with respect to the electric field and radius. All other terms are constant, so we can neglect that. So E square is inversely proportional to R square. So we are taking square root on both the sides, means we can write E is inversely proportional to R. Now we will substitute the condition. In the first condition, maximum electric field is 100. So 100 is inversely proportional to radius R. And coming to second condition, we have to find the maximum electric field. E is inversely proportional to, since the diameter became half, because of that radius also will become half. So we can write it as R by 2. Okay. So if you are taking a ratio, R will get cancelled. So we can write it as 100 by E is equal to 1 by 2. If we cross multiply, E is equal to 200. So the maximum electric field value is 200. With respect to that, we can write the equation, that is E is equal to 200 sine kx minus omega t. So we'll check the option. Option 1 is the right answer. So next one, it's a most important question. In an electromagnetic wave, the magnetic field is given as, they have given the equation for the magnetic field. Then we have to find the corresponding electric field. First of all, the wave is propagating in a positive z direction, that is k cap. And to find the electric field, we can take the formula. Electric field vector is equal to B cross C. Okay, so we have to take the cross product. So E is equal to, we can take it as I, J, K. Okay, so the magnetic field 30 is common. If you want, we can take it inside. So in x-axis we have root 3 by 2. So we can substitute as root 3 by 2 into 30. Again, in the place of j we have 1 by 2. So 30 is common. We can take it inside. So you can write it as 30 by 2. In k vector you don't have anything. So we'll substitute as 0. And next one, c, that is velocity of light. The wave is propagating in a z-axis. So we have to write only in k vector. So 0, 0. In the place of k vector, we can write c, which is velocity of light. So we can take a cross product now. That is I cap or I vector into 30 by 2 into c minus 0 minus j cap root 3 by 2 into 30c minus 0 plus k cap. So if you cross multiply, it will go to 0. Okay. And now we can take the common term out. So 30 into c is common. Balance 1 by 2 I cap or I vector minus root 3 by 2 j cap. Okay. So now we can expand c. So we can write it as 30 into 3 into 10 power 8 into 1 by 2 I cap minus root 3 by 2 j cap. So 30 into 3, it will become 90. You can write 90 into 10 power 8, or you can write it as 9 into 10 power 9 into 1 by 2 I cap minus root 3 by 2 j cap. So this is the maximum electric field, that is E naught. This is the maximum electric field. So the wave function is in the sine form. So we can take only the sine function. And maximum electric field value is 9 into 10 power 9, 1 by 2 I cap minus root 3 by 2 j cap. So we can check the option. Option 2 is the right answer. Okay students, we have reached the end of the session. If you have any doubts or queries regarding this video, do comment in the comment box. And to watch more video like this, don't forget to subscribe our channel. Thank you students.